So today we're thinking about this thing, which I'm going to call doing work. Now that's probably something you're very used to doing in school lessons because you do school work, okay? But this term work has got a kind of specific meaning in physics. We're not going to worry too much about that right now. Let's just think about this guy. So our science friend has got a little spring here, and what we can do is we can obviously push down on that. Now, what I'm doing is I'm working on the spring, okay? I'm actually putting energy into it, so I'm doing work on that spring. Now, there's loads of different kinds of springs. What we might have, for example, is a spring which is a bit more stiff than this. And a much stiffer spring, I'm going to have to work harder onto it to make it go through that distance. I'm going to have to use more force on it to make it go through that same distance because, well, if it's stiffer, it's harder to work upon, okay? Anyway, I push down on him. I've done work on the spring, and then what happens is the spring is going to do work on him and send him up into the air, all right? Now, what that means, what is happening is when I do work on this, I transfer energy into it. And then when the spring does work on him, then it transfers energy out of the spring and into him. So when we do work on something, we put energy into it. So let's think about some other examples. So basically, as we start talking about this, work is just another way of talking about energy. Doing work is talking about putting energy into something, okay? Now, for example, let's look at another simple situation, right? So we're going to have a box on the ground and we're just going to have a crane, okay? So let me just crudely draw a crane on a construction site. Maybe it's a box of bricks or something like this, okay? And there is our crane. See why I'm not an art teacher? So what we've got is we've got this box and it's going to get lifted up through a certain distance. So some work is being done on it. Now let's think about the things which actually affect how hard it is to do that work. Well, this has got a mass, right? But it's not mass we're concerned about. We're concerned about the, because, you know, the mass could involve moving it in any direction. What we're actually concerned about is its weight, okay? And if you remember, well, if I move it through this distance here, let's say it raises by 10 meters. Let's use some of these colors. Let's say we lift it by 10 meters. What it's going to get is a certain amount of gravitational potential energy, which is just mass times the strength of gravity times the height it's moved through. So when we lift it up, we do a certain amount of work on it. And that is equal to the gravitational potential energy it gains. Excuse me, I'm a bit sniffy today. The amount of work we do is equal to the gravitational potential energy it gains whenever it has moved through this height. So let's say it's moved up to here. Now, there's a simpler way we can talk about this and a more general way because we don't just, we can think about it not just lifting, but also doing work by pushing things and pulling them and this kind of thing. All right? So what we've got here, mass times gravity. Now, we know that weight is equal to mass times gravity. And weight is just a force. So what we can then say is work done on an object is equal to the force used on it multiplied by the distance in the same direction as the force. So I don't really know how to pause the recording. So here's our just more general equation for work done. So work done is equal to force times the distance in the same direction as the force. Now let's look at another example which will hopefully help to clarify this. So we'll think maybe about a car. And when we think about cars, we like, because it's much simpler to think about a car on a straight, flat road. Because then we don't have to worry too much about changes of direction, this kind of thing, which does actually make it a bit more complicated. Let's just do a crude drawing of a car. There we go. Okay, so it's moving also at a constant velocity of, and we'll just say of 10 meters per second. Okay, because of course 0 could be a constant velocity if it's not changing. Right, now one thing we probably remember is if it's at a constant velocity, that means that the force from the engine is equal to the force of air resistance, or friction, let's just say. So we'll call that E, and we'll call this F. Okay, there's your friction, air resistance, and whatever. Now, if you've ever been physically moving, which I'm sure you have, you will know that we need to keep using energy to stay at that speed. Okay, so the engine must be producing some amount of energy. The engine is doing work on the car. Okay, and so what we want to think then is about, okay, so how do we find out how much work the engine's actually doing on the car? Well, look at this. It is just work done is just force multiplied by distance in the direction of the force. Now, we don't know these things yet, so the question will probably give you certain figures for those. So the force from the engine is, let's just say, we'll keep it simple, it's 1500 newtons. And the distance is, well, whatever distance we like, but let's say 100 meters. So the work done is just, work done is force times the distance in the same direction. So we just do 1500 multiplied by 100, which will give us 150, hold on. Yeah, 150,000. Now remember, let's think back, work done is just a certain amount of energy, okay? So then our units for work done is just joules. So here we've got this thing. A car is moving at a constant velocity on a straight flat road for a certain distance, and to get the work done, we just multiply those to the force from the engine by the distance. Another thing we can also work out just by looking at this is we can also say that the force of friction, okay? Well, the force of friction. We could say the force of friction because it's moving at a constant velocity. So that means that the force of friction is just this here. Okay? So there we go. Let me see. I'm gonna split this video into a couple of parts. So there's the first video.